Okay, so we're solving nonlinear systems. So that means I might have one linear, but then the other one is going to be something that is nonlinear or not a line. So all of the ones we're doing today will be a quadratic equation, which is like a parabola, and then a linear equation. So we have three types of answers. We either have no solution, one solution, or two solutions. And what you are looking for, or what you're trying to find, is the points where they intersect. So if I have a line here and a parabola here and they don't intersect or touch at all, then I don't have a solution. If they intersect at exactly one point, then I have one solution. And if they intersect two times, then I have two solutions. So my solution is wherever they cross. So it would be this point right here, this point right here, this point right here. So the first thing we're going to talk about is how to solve the system by graphing. All right, so you want to make sure that you have isolated the y. Y is by itself, which I think most of these are already done for you. All right, so I'm going to graph this equation, and then I am also going to graph this equation. So I'm literally just going to put them in the y1 and y2 of my graph. So we are going to grab our calculator, go to the y equals button, and for the y1, we're just going to be putting in the right-hand side. So we have 2x squared. You can also use the little caret if you want to get the number up top. Okay, plus 5x minus 1. In the second equation here, we are going to put the x minus 3. So remember, we're solving a system, so we will be looking for where they intersect. So press the graph button so that you can see both of these graphs. The first one will be your parabola that graphs. The second one will be the line. As you can see, they cross one time right here. Now you could take an educated guess and say that that would be, maybe negative 4. Okay, but if you're just not completely sure, then you can have your calculator calculate that for you. So you have a calculate menu up here above trace. So I press second, trace, and what I'm looking for it to calculate is the intersect. So I'm going to choose option 5. All right, so really it's going to ask you a few questions. First one is, are you on the first curve? So you want to be close to that point of intersection because sometimes you have two. So I'm going to arrow to the left and kind of move that little spider-looking thingy along my blue line. So this is all in blue, so that shows me that I'm on the parabola. So I'm going to press enter. Then it says kind of like, are you on your second equation, which everything turned red, so you know that you're on the second equation. Make sure that your little Spider-Man is right here close to that point of intersection. Press enter, and then it's just going to say, would you like for me to guess what that point is? And we're going to say yes by pressing enter. And then your little spider should turn into 1 and move to this point. Now sometimes it might give you point 0.0000007 or 0.0003. Okay, you can just round to the nearest whole there. So it's telling me my point of intersection is when x is -1 and y is -4, which is what I was kind of guessing anyways. So that is my answer, the point -1, -4. -1, -4. Make sure you enclose that in parentheses and separate your numbers by a comma. All right, so we're going to do the same thing on number 2. So go back to your y equals. Make sure you clear out anything that was there. So my first equation was y equals 3x minus 15. So I've got 3x minus 15. All right, and in the second equation, 1/2. So I'm going to get boxes here for a fraction. So I've got 1/2 x squared minus 2x minus 7. And then I'm going to go and graph that. The first one this time is going to be my line, and the second one will be my parabola. All right, so you're going to notice that this one is going to cross in 2 places. So we actually have 2 answers, whatever this point is and whatever this point is. When they get farther away from the origin, it's harder to tell kind of where they're at. You can kind of guess, but it's always good to just have the calculator do that for you. So I'm going to go to second trace. I want to calculate the intersect. Now, since we have 2, you're going to have to kind of guide your calculator in giving you those answers. So if you look right now, your little spider is sitting at 0, -15, which is like way down here. So I want to kind of arrow to the right until he comes back up the line. Okay, and then I'm just going to stop close to where this intersects at. So I am on my first curve or my first equation. All right, now everything is red, so I know that I'm on the red equation, and I am close to that point where it's flashing. Okay, and then it's going to say, do you want me to guess? I press enter again, and I should get one little spider guy right here on the intersection, which is at 2, -9. So I have one point would be 2, -9. So now I need to find the other point of intersection. So I'm going to do the same process, but I'm going to make sure that I put my little crosshairs really close to that point. So the calculate menu, which is second trace, I'm going to go down to intersect, which is option 5. And then see, I'm way down here, so I'm going to arrow to the right until I get close to the other intersection. That way it kind of knows like what I'm talking about. So I'm really close to that intersection. I am on the blue line, so I'm going to press enter. Now it says, are you on the other one? My answer to that would be yes, and I might even arrow a little closer. Enter. And then it says, you want me to guess, and you say enter for yes, and it should go up to that point right there, and that point is 8, 9. So I have another answer at 8, 9. So I have 2 because it crosses 2 times. All right, a second way for you to solve these systems is algebraically. So the first way we're going to do that is by substitution. That just means I'm going to take something from maybe the first equation and plug it in to the second equation. So if I'm looking at problem number 3 here, I know that y is equal to x squared plus x minus 1. That means they are interchangeable. So I can take all of this right here, and I can plug it into the other equation for y, because y is equal to that. That means I just take this y out, and I'm going to replace it with everything in this box. So x squared plus x minus 1. All right, then I just write the rest of the equation. Equals -2x plus 3. So now I have nothing but x's, which means I can solve for x. And anytime I see that I have an x squared, numbers with just x's, I've got numbers without x's, that means that I'm probably going to want to try to factor this. All right? Well, in order to factor, I need everything to be on one side. So I'm going to move everything to the left since this is a -2x, and I'm moving it across the equal sign. I'm going to add 2x. Now, I need to put it with its like term, which would be the 1x right here, so I'm going to kind of line it up right there. All right, I also need to move this 3, so I'm going to subtract 3 and put it with its like term, the -1. That means everything over here cancels out and gives me 0. So if I do the math, I've got x squared, 1x and 2x are going to give me 3x, and then -1 and -3 give me -4. So now I have this trinomial that I'm going to factor. So I look at the back, I have a minus sign. That means I'm going to have a plus and a minus. I have x squared. That gives me x times x. And two numbers that multiply to make 4 and subtract to make 3. So that would be 4 and 1. Since I look on the front right here, I want this to be a positive 3 in the middle, so I'm going to put the bigger number with the positive. So 4 will go here, 1 will go here, and then I just set those equal to 0, and solve for x. I subtract 4. 0 minus 4 is negative 4. Over here I will add 1. So I get x is equal to 1. Well, the problem is that I don't just want the x values of where they intersect. I want the y values as well. So in order for me to find the y values of the points, I need to plug in the x values that I just calculated. So I can plug into this top equation if I want to. I can plug into the bottom. It doesn't matter. I'm going to get the same answer no matter what I do. So since the bottom is a little less involved, I'm going to choose the bottom. So I have y equals, and then in place of this x right here, I'm just going to plug in negative 4. So that gives me negative 2 times negative 4 plus 3. You can plug that into your calculator. You can do it by hand. That gives you a y value of 11. So that means they cross when x is negative 4 and y is 11. So that's one point of intersection. The other one, I'm going to do the same thing, but instead I'm plugging in 1. So I'm literally taking the same equation. Instead of plugging in negative 4, I'm going to plug in an x value of 1. When I do that, I get a positive 1, and that's my y value. So when x is 1, I get a y value of 1. So I cross at negative 411, and my graphs cross at 1, 1. Now, you could graph those two equations at the top and look at where they cross to check your answer. Okay? Again, solving by substitution. So I know in this top part that I've got y equal to x squared plus 4. Well, that means I can take that and plug that in for the y value down here. So that gives me x squared plus 4x. So I've replaced the y. That's what substitution is, replacing. And then I've got equals negative 4. Well, I see that I have an x squared. I have a term that has an x, and then I have a term that does not have an x, which should lead me to believe I'm going to factor. So I'm going to go ahead and add this number and move everything to one side. So that gives me x squared plus 4x. And then 4 does not go with either of these, so it will go at the back. And then I'm going to factor. So I look at that trinomial that I have. I see that I have a plus at the back, which means I'm going to have 2 of what is in the front. To get an x squared, I have x times x, and what multiplies to make 4 and adds to make 4 is 2 times 2. I look at that, I have 2 of the same, so I really don't need to set both equal to 0. Okay, I would get the same thing. So I just set 1 equal to 0. I subtract the 2, and I get x is equal to negative 2. Now, if I use my brain a little bit here, I realize that I only have one number to plug in, which means I'm only going to get one y value. And if you look up here, it already tells you that y is negative 4. So I could immediately just realize that my point of intersection is negative 2, negative 4. Maybe I don't realize that, though. You can plug into this equation up here because there are x values that you could actually plug into. If you do that, you just want to make sure that you put parentheses around your negative 2 when you plug in right here. So I've got negative 2 squared plus 4 times negative 2. That would give me 4 minus 8, which is negative 4 for a y value. So I'm still going to get it even if I don't realize. But if they tell you what x is or what y is, then you already know that that's your y or x value. Okay? The third way to solve these is by elimination. And just like it states, if you're using elimination, you will eliminate one of your variables. Since I've already paired these up where y is by itself, then y is always the easiest to get rid of because I only have one of those. So I'm going to eliminate the y. If I was trying to eliminate an x, that would be way too difficult to do. Okay? So we are going to eliminate the y every single time. Now, when I say eliminate, that means I want to add these two equations together, and when I add them together, I want the y to cancel out. Well, this is 1y and this is 1y. If I add that together, I get 2y. So I need to think, well, if one of these was a negative 1, then that would cancel out. 1 and negative 1 make 0. So what I'm going to do is I'm going to take one of the equations and I'm going to multiply it by a negative 1. I have to do that to every term in here. So I'm keeping this one. I'm just going to go ahead and write it down below. I like to keep them together. All right, and then I'm going to multiply a negative times all of this. So negative 1 times y is negative y. Negative 1 times negative 3x, positive 3x. And negative 1 times negative 8 is positive 8. Now, I kind of want things to line up. So if you look at this, this is lined up. X squared, I don't have an x squared. So what I'm going to do is I'm going to kind of shift these where they go. So in other words, this was a positive 3x and then a positive 8. And see how I've lined up with their like terms now? So if I go through here, y minus y, okay, that's 0. X squared, there's no other x squared, so I just have x squared. Negative 3x and positive 3x, well, that cancels and makes 0. And negative 2 plus 8 gives me 6. So I look at this and I see I just have x squared. I don't have any x's. So I can solve for x squared. So I will subtract 6. So I get a negative 6 equals x squared. To solve for x, I would square root and not forget that I have a plus or minus. That cancels. So I have x is equal to plus or minus the square root of negative 6. But as we all know, we don't square root negatives and leave them. So I will split this into 6 and negative 1. All right, as we have previously studied, 6 is the product of 2 and 3, which are both prime numbers. So I'm going to leave 6 underneath the square root because I can't split that into a perfect square. And then the square root of negative 1 is I, so I'm going to put the I in front of the square root of 6. All right, so here's the thing. I got an imaginary answer. And anytime I square root a negative, I know that I'm going to have an imaginary answer. So if you had stopped right here, that would have been fine. Since I don't have a real number, that means that these are never going to cross. So therefore, this would be no solution. You could also just put a 0 with a slash through it. Either of those answers is fine. So in the end, if you get, a negative under a square root, that should lead you to there are no real solutions. Okay? All right, so I'm going to do the same thing over here. I'm going to eliminate the y. That is the only one we're going to be eliminating. I'm just going to do the same thing. Since it's 1y and 1y, I just want this to be a negative 1y on the bottom. So on top remains the same. I have y equals x squared plus 2x minus 5. On bottom, that's going to change this to a negative y. Negative 1 times 2x is negative 2x. And negative 1 times negative 1 is positive 1. All right, and notice I lined my like terms up. That way I wouldn't have to rewrite them. So y minus y is 0. I don't have an x squared to put with this x squared, so I just have x squared. 2x and negative 2x, that makes 0. And negative 5 plus 1 is negative 4. So now I'm just going to solve for x. I don't need to factor because I only have an x squared, so I go ahead and add the 4. And I really don't like my x squared being over here, so I'm just going to kind of move it to the left. So x squared equals 4. Then I square root, and I don't forget that I have two answers, a positive and a negative. So I have x equals plus or minus the square root of 4, which is 2. So this is two things. I have an x value of 2, and then I have an x value of negative 2. So now it's the same process as it was with substitution. Once you get your two x values, you must plug in to find your two y values. Now, I'm going to use the original equation, not the one that I altered. So I've got y equals, and then in place of this x right here, I'm going to plug in 2. So I have 2 times 2 minus 1. So I have a y value of 4 minus 1, which is 3. So they cross, these two equations will intersect at an x value of 2 and a y value of 3, so the point 2, 3. Then I do the same thing with negative 2. Y equals 2, and instead of plugging in a positive 2, this time I'm plugging in negative 2 minus 1, which gives me negative 5. So these two graphs also cross when x is negative 2 and y is negative 5. So I have my 2 points of intersection. And if I want to check myself, I'm just going to graph these. Same thing on this. If you graph these two, you're going to see they don't cross anywhere. Okay? And then you could check yourself on number 6 as well. Okay? Now let's talk about what if I have like two sides of an equation. Okay? To solve that, I'm going to create two equations. I'm going to kind of separate them out. The first one is the left side of your equation. So all of this, we're going to make this the y1. Okay? On the right-hand side of the equation, that's going to be your y2. Don't move everything over. So if it says solve by graphing and you don't see any y's here, you're going to make two equations. Okay? So in other words, this is y1 equals this left-hand side. All right, y2 equals the right-hand side. Now it's exactly like the first two problems that we did. We've made two equations. We just want to know when these two equations are equal. That's what we're finding out, the point of intersection. That's when they are the same. Okay? So I'm going to go ahead and grab my calculator. I'm going to go to the y equals, clear out anything that I've got in there. And then I'm going to plug those two equations in. So the first one was 4x squared plus 5x minus 1. It's super important to make sure that you plug them in correctly or you will get an incorrect answer. The right side, or my y2, is 2x plus 1, and then I graph that. So the first one will be my parabola. The second will be my line. And remember, you're looking for points of intersection. When are these two things equal? So you have 2 points of intersection. Okay, the first one is right here. Second one is up here. Now, if I'm looking at this, I can see that this is not going to be at a whole number. Okay, it's going to be at like a half maybe, comma 2. So we're going to have the calculator calculate this for us. So second, trace, we're finding the intersection. All right, now remember, you have two and they're pretty close together, so you want to make sure you get close to the intersection point that you're looking for. Like, I want to be at this intersection. This is the one I'm looking for. So I'm on my first curve, which is my blue line. I'm going to press enter. Second, I am here right next to my intersection, and everything is red now, so I know I'm on the other. Press enter. And then it's going to ask, do you want me to guess? Press enter. And it's going to tell you that that is negative 1.175391 and negative 1.35. We will just round to the nearest, I don't know, let's go with the nearest tenth is good enough for me. Well, let's do hundredths. So 2 decimal places. That means if I look at the second decimal place, I see behind that is a 5. If it's 5 or bigger, you round that number in front of it up 1, so this will be negative 1.18. And then I look at this one, behind the 5 is a 0. That's less than 5, so I will keep it at negative 1.35. So I've got negative 1.18, comma, negative 1.35. All right, so that's just one point of intersection. I'm going to do the same thing for the other. So I go back to the Calculate menu and choose the intersect. And then make sure that you arrow over close to that other point of intersection. So I am on the blue line. I am on the red line. I want you to guess. And it tells me that point of intersection is 0.4. I look behind the 2, there's a 5, so I round up to 3. I look behind the 5, there's a 0, so I round up to 6. I stay at 5. So I have negative 0.4, or not negative, positive 0.43 and 1.85. And those are my 2 points. So we will do the same thing with this one. You have 2 equations. The first one is the left-hand side of your equation. So that would be your y1 is 3x squared minus 4x plus 1. The second equation will be the right-hand side, which is 4x minus 1. Okay? So I'm going to go ahead and put those in my calculator. So the left-hand side was 3x squared minus 4x plus 1, making sure that I'm careful about putting my numbers in. And then you have 4x minus 1. Graph that. The first one will be my parabola. The second will be my line. All right, so we have 2 points of intersection. Okay, so I'm going to go ahead and have my calculator calculate that for me. Go to intersect. Make sure that you're really close to that point of intersection. Enter. I'm on the second curve. Enter. Guess. Enter. So I have 2.28 and 0.12. So 0.28, 0.12. Then we're going to have it find the other point of intersection. So back to the Calculate menu, option 5. Make sure that you arrow over and get really close to that point of intersection. So I'm on the blue line, I'm on the red line, and I want you to guess. Make sure that your little guy is right there on there. So I've got 2.39 and 8.55. So 2.39 and 8.55. So 2.39 and 8.55. So on these ones where they don't give you the y in the front, sometimes you get the decimals, and that's fine. On the ones that you do by hand, I'm fairly certain that you really don't, you won't get decimals. You might get fractions.